Hey everyone, welcome to Tech Wired. In this linear algebra series, in the last video we ended up with the vector representation and scalar representation. And in this video we are going to see, first we are going to see is multiplication dot product. Multiplication dot product. Okay. So what it is? So a dot product will be represented as with a dot. So in order to multiply two vectors, here A and B are vectors. A vectors is not, typically it will be n dimension, right? As I said before. So we can write this one as A as A1, A2 till n dimension. So this is 1 cross n, and B as B1, B2 till Bn 1 cross n, right? So A dot B can be written as, so you need to do a transpose either B or A. You have to do a transpose. We will see what is a transpose in a minute. So A transpose B. Then you do the normal multiplication. So what it is? Why we need to do transpose? Okay. So typically if you know matrix multiplication, you need to have this dimensions. Okay. So the dimension of the column of one vector should match with the row of the another vector. Then only you can matrix multiply. Okay. So what is transpose is, if I do A transpose, we will be getting A1, A2 till An. Now this representation is n cross n. Now I can multiply this one with this B. How? Now 1 is equal to 1 here. So now the multiplication is valid. So the multiplication will be done. So this is the A dot B. The multiplication will be done component wise. A1, B1 plus, you need to do plus. After doing a component wise multiplication, we need to add a plus. Then A2, B2 and so on, An, Bn. This one can also be represented as summation I is equal to 1 to n Ai Bi. Now, typically a vector in data science will always be a column representation. Okay, this is a default one. A vector will always be a column vector. We also saw when you have one row and n, when you have n row and one column, this is called a column vector. When you have 1 cross n, that means one row and n column, then it is called a row vector. Okay, now we will see how to calculate angle between two vectors. Okay, angle between two vectors, that's what we are going to see. Angle, we are going to calculate this area. Okay, so assume I have 2 points A1, A2. So this is nothing but x1, x2. So this is A1, this is A2. This assume B1 comma B2. Okay, so this is B1 and this is B2. I need to calculate this angle between these 2 points, 2 vectors. Now we are not seeing any scalar like a point. We are going to see it from a n dimension, a vector perspective. Okay, so what it is? What is this part? This is the length, the distance, the length of a point B from the origin can be represented as norm of B. We all know this is called norm. The double bar is actually known as norm representation, and the distance of origin of this particular point A is norm of A. You have to know this. This is also called as length or distance from the origin of point. Okay, so here the A dot B, we saw this is the dot product, right? This can also be written as A1 B1 A2 B2. That this one we saw in the previous slide. A dot B is also equal to norm of A, norm of B, cos theta, the angle. Now the angle can be calculated as theta is equal to A dot B divided by norm of A, norm of B. This is the, if you know A and B, we can able to calculate theta. So what is norm here? We haven't said what is norm. I'm writing it here so that I can finish it up in this page itself. So what is norm of A? Norm of A is nothing but we have A1, A2, right? Nothing but A1 square plus A2 square, the whole root. That is the formula for norm of A. Now we will see perpendicular of two vectors. What will happen? Assume we are all giving examples in 2D representation so that it will be easy for us to understand. Okay, so assume this is x1 and this is x2. Okay, I have A here and B here, B1 B2, and here A1 A2. Okay, this is the angle. This is a 90 degree. So we know A dot B is nothing but norm of A, norm of B, cos theta. So here theta is 90 degree, right? 90 degree. What is 90? Cos 90 degree? It is 0. So your A dot B is equal to 0. So whenever your vectors are perpendicular to each other, you are going to have value 0. This is also applies to n dimension. This is a 2D dimension. This is also applied to n dimension. When you have n points, this also applies to n dimension when at least one point if it is perpendicular to each other, then you're going to get a value 0. What if you have a point only a single vector? That's a possibility. That's the case. Edge case, right? So what if you have only single point from the origin? A1. Okay, so assume this A. Okay, some n dimension. Okay, what if you have only one vector rather than two vectors or multiple vectors? Then it is A dot A. Okay, so you're going to get A1 A2 A1 A1 A2 A2 plus A3 A3, so on, AN AN. So you're going to get the norm of the square A itself. Like you're multiplying two norms of A, you're going to get norm of A square. Okay, your dot product. Why we are showing examples in 2D representation? Because it is easy to understand. Okay, it's easy to understand from the geometric perspective. Then only I can able to explain the theory and the mathematics behind these concepts. We cannot visualize 3D, right? This is the representation a human can visualize. Okay, that's the reason we are following. Now we are going to see projection of a point on another point. Okay, so assume we have point B here. We are not putting it in 2D like in a typical graph. We are just putting the points alone here. Okay, and this is A, and you have n dimension points, and here also you have B1, B2 until Bn. Okay, now we have angle here, and we need to calculate. So what is projection of a point on point? Projecting A on B, this is the distance we need to calculate. Okay, now the distance of A, we have seen this previously. The distance of A from the origin is norm of A, and distance of B from the origin is norm of B. Okay, the projection of point on a point, this D can be represented as norm of A, the length of A, into cos theta. This is the formula, and we know our previous formula of A dot B, the dot product. We know norm of A, norm of B, cos theta. Okay, we know this. Now substituting D here, you're going to get D norm of B, right? Now D is equal to A dot B norm of B. This is the formula of this distance. That's all for this video. We still didn't arrive to the beauty of linear algebra itself. Then why we are learning all these basic concepts? Because you need to know these concepts to appreciate the connection of linear algebra to data science and machine learning. We will see that in the next video. Please like and subscribe. If you have any questions, message me in the comment section so that I can answer your queries. Happy learning. Cheers.